Okay, the next video that we're going to look at is about using area or volume in calculations. You'll have a certain amount of these formulas given to you in your formula sheet. You'll have things like the area of a circle, the volume of a cylinder, but then there are some others, for example the area of rectangles and triangles, volume of cuboids, that you need to know for yourself. And we're going to approach this from the point of view of being able to use a calculator, because that's often how these problems come up. Okay, so here's one where we talk about Miss Jameson painting a pixie on the wall of a nursery class. And it says the face of the pixie is a semicircle, this little bit down here, and the hat is this triangle. And I have to work out the area of the painting. There's a few pieces of information that we just have to kind of bring out of the question before we can start using our formulas. So what we've got is a semicircle down here, and we know that the distance across the semicircle is 38. So that means that this part here, which is important, the radius of the semicircle is going to be half of that, which is 19. We need the radius for our formula in order to find the area of the circle, because we use pi r squared. That means then that this little bit of distance here is 19. And when we come to work out the area of the triangle part, then we need to know the base of the triangle, which is down here, it's 38, but we then need to know the height. Well, from the bottom to the very top is 57. This little bit here is 19, so we would do 57 take away 19. We could even use the calculator for that if we wanted. 57 take away 19 is 38. Don't need to use a calculator, but if you need to and it helps you, do it. Don't run the risk of making arithmetic mistakes when you could just use your calculator to double check it for you. Okay, so what I need to do to work out my area is I need to use the area of my circle and the area of my triangle, and then I need to add them. So let's call the circle area 1. Okay, well, that is pi r squared. We can use the pi button on our calculator, or we can use the number 3.14, as long as we make it clear in our working. I'm going to use 3.14 so that I don't need to round as much by way of decimals. 3.14 times the radius of 19 squared. I'm going to then go to my trusty calculator. Yours might look something like this. 3.14 times 19 squared, and then equals. I get this weird looking fraction. That's fine. Remember, if you're using a Casio calculator, you've got this little S and D button. Press that, and that tells me that's 1133.54. 1133.54 centimetre squared. I'll leave that like that just now, I don't need to round it. So area of my triangle, let's call that area 2. Well, that's a half base times the height, so that's a half times the base of 38 times, well, the height is also 38. Okay, and let me go into the calculator for that. So a half, I'm just going to put 0.5 times 38 times 38. That's 722. I want to then give the area of the total thing. So that area, my final answer is going to be area 1 plus area 2, so it's going to be 1133 10.54 added on to 722. I'm going to go back to my calculator. I had 722 in there already, so I'm just going to add on 1133.54. Again, strange fraction. That is 1855. 1855.54. If the question tells you how to round it the way the question tells you. If not, well, I'm just going to maybe round that to the nearest whole number. 1856 centimeters squared. Regardless of if the question tells you how to round, you have to write the exact number from your calculator before you round anything, otherwise you might lose a mark for rounding even if you round correctly. Okay, let's just look at this one really quickly. I'll just do two examples of this one for you for the video. You should be able to work out any others by yourselves. So this says that Ben is building a new shed. You need to read the question quite carefully. It tells the side of the shed is a square and an isosceles triangle, and I think that might come in useful as information later. So if this side of the shape is a square, that means that that's 7, that's also 7 there, and that's 7 there. That allows us to find dimensions for our triangle, because it means that this side here is 7. So if we were to split up this part, we have 7, and 10 take away 7 is 3. Okay, so the area of the side of the shed, well, area 1 is going to be my square. So it's going to be the length of the square squared, or length times breadth if we want to write it a longer way. Well, that's 7 squared. You have access to a calculator, but we could do that without. 7 squared is 49 centimeters squared. Area 2 is a triangle, so it's a half base times height again. So it's a half. The base of the triangle is this part here. I'm moving the pen over, so that's a half times 7. The height of the triangle is times 3. What does that equal? Well, I'm going to use a calculator for that just to be on the safe side. A half, 0.5 times 7 times 3. Again, a fraction, 21 divided by 2, which is 10.5. Centimeters squared. The total area is equal to area 1 plus area 2, it's 49, plus 10.5. I'm going to use a calculator here just to be on the safe side. 10.5 plus 49, I don't want to make any silly mistakes, is equal to 59.5. Don't think I need to round that, that's a nice easy number to work with, but what I do need to pick up on is that I've been saying centimetres squared all the way through. It was actually metres squared. So mistakes happen, but at least I caught it at the end and I made sure that my final answer had the right units. And if I was doing this at the test, I would go back in with a rubber. The rubber on the board here is a little bit big. I would say that's 49 metres squared. I go back in and be a bit less clumsy with the rubber, and I just change that centimetres to metres, just to make sure that I'm using the right units all the way through. Again, this is one of those times where at the end of the test you might be looking back over your paper and saying, why would a shed be in centimetres squared, and you would notice and pick up and fix that mistake with units.